Good morning, sir. I am Akshikal. Today, I am going to start with the assignment, first part of my assignment. So, this is the first part of my assignment, which is the crystallization of the crystal provided. So, you are provided with the sugar crystals to us. We have to find the point group of these crystals. So, to find the point group of this crystal, firstly, we will analyze its structure, its physical properties, its appearance, and all this stuff. So, start with the structural characteristics and the symmetry. Firstly, we will look at the physical appearance. Typically, prismatic or blade-like shape with elongated faces along one axis. So this is the shape. We can look at this structures. Second, the point group. We will analyze this point group, and this point group has come out to be 2 by m, characteristics of a monoclinic crystal system. For monoclinic, A equal to B equal, A not equal to B not equal to C is the properties of its side, and also alpha is equals to gamma is equals to 90 degree and beta not equal to 90 degree. 2 by m is two fold rotation axis and m represents the middle plane. Symmetry elements. Two fold rotation axis runs along the longer crystallographic axis, often the B axis, allowing the 180-degree rotation that brings the crystal to an identical configuration. Middle plane. Position perpendicular to the rotation axis, reflecting the crystal's structure across this plane, creating symmetrical halves. Now we will give the justification for the point group 2 by n, that how and why it's coming 2 by n. So firstly, key symmetry elements. So there are the two symmetry elements. First is the two-fold rotation axis. The crystal has a two-fold rotation axis often aligned with the B axis, allowing it to rotate 180 degree about this axis. This rotation brings the structure back to an identical orientation, which is the characteristic feature of a 2 by m point group symmetry. Second is the mirror plane M, perpendicular to the rotation axis. Mirror plane means when we will take the mirror image of it, then we will get the similar structures. The mirror plane divides the crystal into symmetrical halves. This plane reflects atomic position across it, resulting in a balanced structure that meets the criteria for the 2 by m symmetry. Second is the monoclinic characteristics. That is a monoclinic type structure. The monoclinic crystal system is defined by alpha is equals to gamma is equals to 90 degree and beta not equal to 90 degree, creating a unique asymmetrical tilt. This angle beta introduces a slight skew, giving the crystal a form that supports 2 by m symmetry but remain distinct from other crystal systems. Observed morphology and symmetry alignment. The prismatic or blade-like shape combined with the two-fold rotation axis and mirror plane creates a crystal morphology that matches the 2 by m point group. This alignment between observed morphology and internal symmetry confirms that the crystal falls under the 2 by m point group in the monoclinic crystal. So, finally, we can conclude that its point group is 2 by m, and how it's come 2 by m we have to find it. So the conclusion is that symmetry verification for 2 by m point group. The combination of the two-fold rotation axis and the perpendicular mirror plane aligns with the monoclinic crystal morphology, confirming its classification within the 2 by m point group. Second, monoclinic characteristics confirmed. The distinct beta angle and observed prismatic structure validate the crystal's monoclinic system properties, reinforcing the alignment between theoretical symmetry elements and the observed form. So this is the PPT representing that the sugar crystals that you have given is having the point group 2 by m, means two full rotation axis, and m represents the mirror plane.